The Earth is a sphere, and it is difficult to represent it on a flat surface. To do so, it has to be projected. There are many types of projection, but the one most commonly used at sea is a Mercator projection. It projects the sphere onto a cylinder. Because the resulting distances between the latitudes are constantly increasing, it is called a progressive projection. The advantages of the Mercator projection is that longitudes and latitudes are at right angles, and it makes it easy to read true bearings. At small scale, the Mercator chart also gives true distances. Unfortunately, because distances in longitudes are equal to the cosine of the latitude, the Mercator projection cannot really be used near the poles, where distortion reaches its maximum. As an example, a Mercator projection at latitude 60 degrees north gives a 1 by 1 degree rectangle, which is twice as high as wide, the cosine of 60 degrees being 0.5. Small-scale charts are always based on a Mercator projection. The nautical mile is by definition 1 minute of a degree of latitude. 1 degree is traditionally divided into 60 minutes, with each minute divided into 60 seconds. Today, however, nearly all nautical charts and navigation instruments indicate degrees, minutes, and tenths or hundredths of a minute. 1/100th of a minute of latitude corresponds to 18.52 metres, and this exceeds the accuracy of most navigation systems' or charts' resolution. Dead reckoning is obtained by measuring the distance covered since the last position was noted, and drawing as an equivalent line the direction sailed. Note that on a Mercator chart, distances always have to be measured from the nearest latitude scale, as it varies from each latitude. The Earth is not a perfect sphere. This wasn't a problem until satellite navigation systems started to give positions in 3 dimensions. To do this, the calculation assumes a perfect sphere and corrects the elevation at the actual place of observation. This correction is called a geoidal height. Charts are relatively accurate, but they were drawn long before satellite surveys were available. In order to correct charts to the extreme accuracy of satellite positioning, a standard reference had to be created. The World Geoidic System of 1972, superseded by the WGS 84 in 1984, are the reference datum charts that should be corrected for when reading satellite system position. Usually, charts will indicate the north-south and east-west correction to be added in order to confirm the WGS 84 datum. The position of a vessel is found by plotting lines of position on a chart. These are found by dead reckoning, taking bearings, or by reading navigation instruments. A line of position is a single line drawn from a single measurement. It can be from the observation of a celestial body, or a bearing from a landmark, or a radio navigation instrument bearing. A minimum of 2 lines of position are necessary in order to assume a position. Usually 3 lines of position are used, and the position is assumed to be inside the triangle or cocked hat created by the intersection of these lines. Note that if lines of position from celestial observations are in fact curved lines, at a small scale they can all be drawn as straight lines. A vessel is said to sail on a course. However, one must differentiate between the direction in which the vessel is pointing, the heading, and the direction in which the vessel is travelling relative to land, the the ground track. The difference is the result of the combined action of the tidal stream, currents and wind speed, and is called the drift or leeway. Plotting the dead reckoning position requires the plotting of a vector based on the heading and the distance sailed through the water, followed by the plotting of a vector of the drift. The resultant of the two vectors is the estimated dead reckoning position. Today, all electronic navigation instruments give the calculated position in degrees of latitude and longitude. To plot the position is a simple matter of drawing the intersection of the given latitude and longitude. Chart work is best done with a pencil and a slide ruler or parallel rulers. When the position is plotted, the following notation is made: the time, the log counter reading, and eventually the words fix or DR to denote if the position was obtained from an instrument reading or from dead reckoning.